Okay, so we're in chapter 4 right now, solving equations by factoring. And, you know, we used the last unit to come up with these techniques, to determine how to break down these polynomials. We were good with linears, quadratics, and cubics. And so the idea is first set the equation equal to 0. And then second, so you get a times b equals, and then factor. Maybe a times b equals 0. Maybe you get like a times b times c times d equals 0. Regardless, you know that from basic arithmetic, you know that if you have something times something equals 0, then you know that a equals 0 or b equals 0, and you can extend that to maybe you fully factored a quartic. The idea is a equals 0 or b equals 0 or, not and, or c equals 0 or d equals 0. And so this is what we were hoping for. If we can get it factored, we can set it equal to 0. And so we know, I give you x squared, plus 5x minus, 14 equals 14. You set it equal to 0. You hope that you can factor it. X plus 7 times x minus 2 equals 0. Yay! We factored it. X plus 7 equals 0, or x minus 2 equals 0. Answers x equals negative 7, or x equals 2. You could do that with, it looks a little weird, so like x cubed. How about like 2x cubed minus, how about 2x squared equals, guys, 24x, right? And so, same idea. You set everything equal to 0. You factor out a 2x. You continue to you keep factoring until you're breaking it out. You're like, okay, we gotta have a linear and a quadratic. Let me factor some more. X minus 4 times x minus 3. Oh, look, I have the product of 3 terms set equal to 0, each set equal to 0. So we have 2x equals 0, or x minus 4 equals 0, or x minus 3 equals 0, and you have 3 solutions. X equals 0, 4, or negative 3. Okay, well, does this apply? Does it have to be polynomials? The answer is no. As long as you have something times something equals 0, you're in good shape. And the book gives some examples of it. So, for example, if you see e to the x minus 7 times 2 sine of x minus 1 equals 0, you see, maybe you don't know how to do this, but still, you look at the structure of the equation and you say, oh, you know what? It's something times something equals 0, therefore it's the first part equal to 0, or the second part equals to 0. Now, I expect you to kind of know how to solve this by hand. First of all, e to the x equals 7, so x equals ln of 7, or we have 2 sine of x equals 1, sine of x equals 1/2. Where is sine positive? In the first and the second. What is the reference angle? The reference angle is 30, because we know from last year the sine of 30, or pi over 6, is 1/2. And what's the reference angle in the second quadrant? 150 is 30 degrees away from the axis. So it's either x equals 30 or 150. I'm not good at speaking the language of radians, but I should get better. It's pi over 6 and 5 pi over 6. Nevertheless, the structure is, I mean, hence the chapter name, algebraic structure. The structure is something times something equals 0. Each part is equal to 0. And then you get some trick questions. They seem a little tricky, but they're not really tricky. You have to recognize, you have to look at it and be like, I see what's going on here. So for example, in the book they have 6 to the x minus 4 times 3 to the x. Those equals to each other. I'm going to recommend in life, just set everything equal to 0. You don't want to accidentally divide by 0. So you know what? Set everything equal to 0, factor something out, and then set the parts equal to 0. Okay. 6 to the x minus 4 times 3 to the x equals 0. What can I factor out of here? Well, from your exponent chapter, I'm going to write this as 3 to the x times 2 to the x minus 4 times 3 to the x. I'm going to pull out a 3 to the x. So I'm left with 2 to the x minus 4 equals 0. I have something times something equals 0. 3 to the x equals 0. 2 to the x minus 4 equals 0. I know by inspection there's no answer. There's no answer here. And for this, x equals 2. So there's only one answer. But the idea is, bring set it equal to 0, try to factor out factor out a common term, and then set them equal to 0. Let's talk, so that we're done. But I want to talk about some more tricks. Because you're asked to factor and then set equal to 0, and so there's these problems that they're cubics, and it's like, without a calculator, factor this. And you're like, how do I do that? Well, here's some little tricks that we haven't spoken about, and they're not part of the course anymore, but it can't hurt to know. There's something called the rational root theorem. The rational roots theorem, and it goes something like this. It's kind of cool. Let's say that you have a polynomial, p of x, and the lead coefficient is a. So bx to the n minus 1, c x to the n minus 2, blah, 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 blah. Let's say the final coefficient is d. Right? Or you know what I should do? I have it make some crazy letter like, let's make it d. So this is the lead, and this is the constant. Okay? If there are rational roots, and there might not be, but if there's going to be any rational roots, then they're going to be in the ratio of a factor of d over the factor of n. So if there are any rational roots, and I'm saying there might not be, if there are, then they are in the ratio of the factor of the lead the factor of the constant d over a factor of the lead. This is kind of interesting. So, if I give you this polynomial, which I just made it up, I have no clue, and it's 3x cubed plus 8x squared minus 7x plus 14, right? If there are any rational roots, then they're in the form of the ratio. So first of all, let's take a look at 14. How do we break, what are the possible factors of 14? It's 14, 7, 2, and 1. What are the possible factors of 3? 3 and 1. And so, this is kind of cool. The possible rational roots are, ready for this? Plus or minus 14 over 3, plus or minus 14 over 1, plus or minus 7 over 3, plus or minus 7 over 1, plus or minus 2 over 3, plus or minus 2 over 1, or plus or minus 1 over 3, plus or minus 1 over 1. Once again, so please remember, we need this like old school. Like if it's 1985, we don't have a calculator, we don't have technology. You have to run through these things. And yeah, the computer would do it for. I mean, it's 1987. You don't have a computer. You don't have a GDC. You can't look at the graph. These were things we had to run through. So, how did you do this? What did we do? Well, we would start plugging numbers in, and the idea was you just start plugging numbers in, and you hope that you got a 0. That was the hope. Now, why am I telling you this? Because you're asked to kind of randomly do a question 2, they give you cubics, and they're like, factor these. Well, when in doubt, if you don't get to use a calculator and you're asked to factor a cubic, so if you have to factor a cubic and you don't have a GDC, my recommendation, start with these two. Start with these two and just run it through the remainder root. Try plus or minus 1 in the remainder theorem. It'll probably work. And you can see it's going to work for 2A, 1 and 2. 2B, you have to try 2. 2 works in that. But once again, they're not asking that stuff anymore. And it's very rare they're asking you to plug and chug numbers into the equations. But when in doubt, try your 1. Now, this got me thinking, is there a cute little rule? And the last thing I just want to talk about is, let's think about, what if, what does it mean? What if x minus 1 is a factor? And I kind of said, so is x minus 1 a factor of ax cubed plus bx squared plus cx plus d? And then I made this interesting discovery. I'm sure I didn't make it. How are we doing for time? Perfect. So I said, okay, let x minus 1 equals 0, x equals 1, put that in the Persh, a, b, c, d, bring down the a, b plus a, b plus a plus b plus c, a plus b plus c, a plus b plus c plus d. If the sum of the coefficients equals 0, then x minus 1 is a factor. That was a nifty little trick I came up with. I'm sure someone came up with it before me. And so these are tricks that we had before we had technology to figure out, how do you figure it out? So the idea is you want to factor these. So once again, just to review, set your equation equal to 0. Try to factor. If you can't figure it out, you can use the rational roots theorem. All these numbers, if there is a rational root, it's in here. Once you got the number, you can use synthetic division to reduce the equation. Try -1, +1. If they get really old school on you, worst comes to worst, try 2 or -2. And then a little trick of the trade is, if after you set the equation equal to 0, if the sum of the coefficients equals 0, you know that x minus 1 is a factor. You could try, for fun, you can try x plus 1. and C2 works. But that's basically it. Okay. Good luck.